Welcome. In this video, we're going to take a look at Unified End User Experience Monitoring, one of the marquee features of the APM967 release. In this video, we'll take a look at how we can use a single appliance to track both the application performance and the end user experience. And we'll see how those are tied together through integrated workflows. We'll start by taking a look at the triage map for our Tick Exchange service. Here we can see that several of the transaction types are showing degraded end user experience. And that's represented by this person over here with a red icon on. Let's take a look at the view item transaction. We'll right click and let's find any incidents that are occurring for users that are performing this transaction. Here we can see that we've had two different kinds of defects. We've had some slow time defects and some missing response defects. The only ones that are current, that are happening right now, are the slow time defects, and we can see that from the time that they last occurred. Let's go ahead and drill in on these defects and get more information. So here we see a list, and you may have noticed we had 46,000 defects overall that we've seen. So obviously we have a very large list showing here. I'm going to sort these by how large their response time is. So we can see we have some 10-second response time values as people are trying to view items while they're shopping on this site. I can see that these are also recent. This is within a minute. This one's a couple of minutes ago. So these aren't from yesterday or anything like that. These are current transactions that are having issues. And one other thing I can notice from here is who are the different servers and clients involved in this. These are all happening on the same client, it looks like, but I do have multiple servers that this client is connecting to. So there's a 190 IP address and there's a 189 IP address. So what I'm interested in is, let's drill into both of those. So the first thing I want to take a look at is I'm going to open this in a new tab. Let's take a look at this one. This is an issue that's happening between 198 and 190. I'll open that one in a new tab. And let's also drill into one of the issues that's happening between that client and server 189. Now this should already start hitting me towards the solution. I have users are accessing two different servers and they're having degraded performance on both. So what are the things that are in common there? Well, it's the same user in both situations. So the issue could be something that's rooted in the location that the user is accessing them from, or it could be something that is common between these two servers, which would be the application itself that's running on both of them. Is it possible that the application has an issue that would affect both servers simultaneously? Well, that's why we're drilling in to find out. So let's take a look at the first server. This is the one with the slowest transaction that we noticed. And if we scroll down, we suspect that it's possible that it could be that it's the location that the client is at that is the issue. And down here at the bottom of this ticket, of course, we have a lot of additional information here. What's the request header? All of the information about what it is that the user is doing on this site. But if we're suspecting that it could be a network issue, what we can do is take a look at the network health information at the bottom. And as I hit the click here link, it's going to take me over to the multi-port collector, which is doing the collection for both layer 7 transaction as well as the layer 4 information. So this is the same system, but I'm now drilling into the session analytic database so that I can view this at a TCP layer and start to identify not just the fact that it's slow, but why is it slow? Is it a problem that's rooted in the network or a problem that's rooted in the server? So the first thing that's going to jump out to me when I get into the multi-port collector is that on the transaction time graph at the top, we're stacking together the network time, the retransmission delay, how long it takes to transfer the data, and how long does it take the server to respond to requests from the client. Well, notice that what is increasing the most, and I'm going to highlight this area when the issue has started, and we're going to set our time frame to that. Notice that what is spiking up is the yellow, so it's taking longer to transfer data, but in conjunction with that, we're also seeing some of this blue color appear, which represents retransmissions on the network. Now, retransmissions are something that is very detrimental to throughput and performance when we're talking about transmitting data over a network. TCP, the algorithm that transmits our data for us, is very risk averse. While it will ensure that the traffic gets there eventually, anytime packet loss occurs, it really throttles back. It always tries to avoid packet loss. So if a retransmission occurs, it's going to slow itself down to try and avoid further retransmissions. So anytime we see retransmission delay occur, it's really almost a sure sign that there's some packet loss occurring within the network. Typically that's going to be due to congestion, packets being dropped in a queue, and that's also going to result in a decrease in performance, a decrease in throughput, an increase in response time. So really anytime we see that blue show up, we're going to go, hey, what's going on the network? We can confirm this by going back up and taking a look at the other session that we had information for. So this was going to the other server. Are we also going to see retransmission delay and increased data transfer time when the client is talking to this other server? And indeed we do. The graphs are mirrored really. So two different servers that are in the same data center. It's the same client. So really the thing that's being held constant here is that the client is having network issues when he's accessing the data center. So at this point we really do have enough information to head up to the performance center and start to investigate why the network is slow, right? So far we've discovered that we have an end user experience issue. Your next question is going to be, okay, is that a network issue, or is that a server issue, or is that an application issue? We've been able to drill in and figure out this looks like it's a network issue. Our next logical step is going to be, why is it a network issue? Why is the network experiencing retransmission? So with that said, let's take a step away from the multiport now, and let's continue troubleshooting this issue. Let's find out why we're seeing these spikes in response time, in data transfer, and why we're seeing retransmission delay occurring. To do that, we now want to focus on the infrastructure. Why is the network being slow? So the first thing we're going to do before we move away is we're just going to keep in mind, what was that client's IP address? It was 130.250.198. I'm now going to head back over to the APM UI. And the reason for that is I've got a quick link here that's going to take me over to the Performance Center where we keep all of our infrastructure data. So I'm going to go ahead and click on Network Status down here in the bottom left-hand corner. And now I'm going to double-click on the More Info button, and that'll take me to the CA Performance Center. Here I'm going to go ahead and search for that client IP address and see if we can find where that client's located. It looks like they're at the Islandia office. So what I really want to look at is, what is the network link like in Islandia? Because I know they're having a performance issue. So I'm actually just going to look for the Islandia network interface. And sure enough, we have a whole site group for Islandia. We have the subnet, which is what we searched and found just a moment ago. That would, if I drilled into that, that would have showed me the super agent subnet. Let's go ahead and drill into that for a moment. So inside of this, we're seeing that sure enough, we have threshold violations from a network perspective and from an application perspective, meaning that the transaction times have increased and the network round trip times have increased, which is what we saw in the multiport. So that confirms what we're seeing again. But what we're really interested in to try and find out why the problem is occurring is we want to go and see what traffic is going across that interface. So let's click on the Islandia interface. So we see a couple of spikes here. This page inside of the Performance Center is being built automatically, and the Performance Center is a place where we're bringing together all of the different data sources that we have. Here we're showing SNMP data from our pollers. We're showing NetFlow data from our NetFlow analysis tool, and we're able to put those right next to each other automatically. So here's SNMP showing me I'm having big spikes in utilization, and those are way above the baseline. I'm normally down here about 50% utilization, and I'm spiking up very close to 100% utilized. And then right below that, I have the information to tell me what's causing those spikes. What is it made up of? And so we can see this is different protocols showing up. Most of the traffic is the TIX exchange, which is what we expect. That's production applications. That we want that to be on our links, right? That's what it's there for. But these big blue spikes are being made up of HTTP traffic. So let's drill in and find out more about that. Now we're inside of Reporter Analyzer. And this is where we're able to see not just the trend graph of HTTP, and again, this is way above the baseline, but as we scroll down, we see what are those hosts? Who are they talking to? Well, it looks like this is users going out to YouTube. So now we're able to tell not just that there was a degradation of performance and that it was a network issue, and that network issue was retransmission delay due to packet loss. We're also able to tell what traffic was causing that packet loss. And we've given you enough information here to say, you know what, this isn't valid production traffic that I need to be able to support. I don't need to be able to support this spike in traffic. What I need to be able to do is either prohibit users from going to this site, or police this traffic, or prioritize this traffic so that it's not going to be interruption to my production applications that are far more critical. Had I arrived on this page and found that this spike in traffic was to a production application that has value to our business, then we might have had to have a different approach and said, maybe we do need to be able to support this spike in traffic. Maybe we do need to resize our links. But here we're able to avoid incurring that cost by saying, no, this is not traffic that we need to be able to support. This is traffic that should be policed or deprioritized so that it doesn't impact our revenue generating or business critical applications. Thank you for joining us. I hope you enjoyed this overview of unified end user experience monitoring and that this helps show you how CA technologies can help you tie the performance of your applications to the infrastructure that supports it.